So now we're going to look at special angles. So this one's going to be the 30, 60, and 30 is pi over 6, and 60 degrees is pi over 3. So they could label it either way. So back to the unit circle kind of. There's the triangle. Ooh, let me redraw that. That's not a very good 30 degree. 30 degrees, more like a third of the way there. Okay, so your 30 degree angle, or your pi over 6 angle, is right here. So I'll put pi over 6. And that means the one up here is pi over 3. It has to be that way because those two angles have to add up to 90 degrees. Your right angle is here. And then here's where we differ. We're not going to be on the unit circle. We're going to say we don't know how big the circle is. We don't know the radius now. And so we use some unit S, okay? And so if you think about what we know about a 30 degree, right? Remember the sine of pi over 6, I'll use pi over 6, was 1/2. So now we want to think of it in terms of, well, what would those lengths be? I could make this 2s and 1s. And we don't know, how long that s is. So if we knew the radius, then, or the hypotenuse, we would know what that is. But it's going to work out okay. And then this one would be the square root of 3 times s. Now, when you take those ratios, like if I've got the sine of pi over 6, it's equal to 1s over 2s, and those s's cancel, right? That's how we get the 1/2. And if I did the cosine of pi over 6, that would be adjacent, so square root of 3s over the hypotenuse, 2s, and those s's would cancel, and you'd get the square root of 3 over 2. So you might say, well, what point is the s? Well, we don't know how long that is on the actual triangle, some unit. Depends on the size of our triangle, right? There's little triangles and big triangles. But if we know the angle, the ratio is still the same. Okay, so that cosine ratio is still square root of 3 over 2 for a 30 degree or pi over 6. Now, this one up here then is 60 degrees or pi over 3. And then you could say the same thing. So you could say, all right, the sine of pi over 3 is going to be opposite square root of 3s over hypotenuse, which is 2s. And so you get the square root of 3 over 2. And you could do the cosine of pi over 3. And you would take the adjacent, up here now, because that's the adjacent, 1s over the hypotenuse, which is 2s. And those s's cancel as well. Okay, so nothing's changed as far as our angles go. We still have those same trig functions for the special angles. And that's the 30, 60 special triangle. And you can also think of it in terms of radians, pi over 6 and pi over 3. The other one is the 45 degree, or pi over 4. And then we're going to draw a triangle then. There's the right angle. And then, like I said, we don't know how big the triangle is, but we're going to make this 2s, and then the square root of 2s, and the square root of 2s. And then this right here is pi over 4. By the way, this one is also pi over 4, but it doesn't really matter. You only have to do one of them. Okay, because those angles are equal. Oops. Oh, sorry about that. I was trying to get something off my screen. Okay, so then if you do the sine of pi over 4, you'd have the square root of 2 over 2. I mean, the s's are here, but those are going to cancel. And if you did the cosine of pi over 4, you'd do, you know, adjacent over hypotenuse, which would be the square root of 2s over 2s, and those s's would cancel as well. Okay, so that's how that's working. It shows it a little bit different in the book, but that's okay.